Good morning. This talk is about optimizing procedures and queries with SQL Server 2005, and I wanted to start off by showing you some optimizations in SQL Server 2008. My name is Bob Boschman. I come from a company called SQL Skills. I work with Kimberly Tripp and Paul Randall. Here's some gratuitous self-promotion information about me. I'm not really good at self-promotion. I've written 2 books about SQL Server 2005, and I'm not going to write a book on 2008. I have written some of the labs on the Always On DVD, and so I've worked on the Always On program. And what I wanted to do is start first, since I was told that you guys are more concerned with SQL 2008 optimizations, is I wanted to talk about the performance enhancements in SQL 2008. Then I will go through my normal SQL 2005 performance tuning lecture. The performance tuning lecture is based upon a list that was made up by PSS, that's Product Service Support, at Microsoft, about the 10 reasons why queries run slowly. And so I'll talk about the 10 reasons why queries run slowly and how you can diagnose these and how you can do things about it. But first to the SQL 2008 stuff. So I'm actually going to do a talk, and I did it yesterday, I'm going to repeat it on Wednesday, about SQL Server 2008 Transact SQL enhancements. So in this talk, I'm only going to talk about the performance enhancements. The biggest performance enhancement is for the analysis type queries, and this is multi-bitmap optimization for star joins. If you've ever done a big analysis query, you notice that in SQL 2005, you can only have 1 bitmap per query. And a bitmap is similar to what other databases call bitmap index. They make up the bitmaps, though, in SQL Server on the fly. They don't make you define and maintain bitmap indexes. They decide that if you have a parallel processor and you can benefit by using a bitmap, they will make up a bitmap for you. In SQL 2005, they would only make up 1 bitmap per query. In SQL 2008, I will show you in a few minutes, they will make up multiple bitmaps per query if they decide you need them. Table valued parameters is a performance optimization, and it's a performance optimization because it's halfway in between regular parameters and bulk copy. At large volumes, table valued parameters approach but don't quite get to bulk copy in terms of performance. But you can use table valued parameters inside of normal stored procedures. Grouping sets is an ANSI standard way to do multiple group by clauses in a single SQL statement. And you do the multiple group by clauses when you want levels of rollup, analysis over multiple dimensions, or a grand total. And I'll show you grouping sets in just a minute. Merge SQL statement. There's a new statement called merge that not only does insert and update in one statement, but also can do delete. So 1 statement for insert, update, and delete. If you did this in 2005, you would need 1 scan through the table for update, 1 scan for insert. In 2008, you only need 1 scan through the entire table. SQL Server 2008 attempts to solve 2 of the big problems in relational design. One big problem that relational cannot handle that well is hierarchical design. And in SQL 2005, they introduced recursive common table expressions. In SQL 2008, they introduced a new data type called hierarchy ID. Hierarchy ID can optimize hierarchical queries. And this is a .NET-based data type, but basically it uses the same type of tree processing that the XML data type does without the requirement of XML. So it's a hierarchical data type, doesn't need XML. Filtered indexes and filtered statistics. If you have a column that contains 90% null values and you want an index, you don't really care to index the 90% null values. You may never query over those null values. A filtered index is a create index statement with a where clause. You decide what part of the table you want to index. Filtered statistics work the same way. I'm going to be able to only get statistics for that part of this table which I'm interested in. Resource governor, there's a man named Boris, I believe, that's going to do a whole talk on the resource governor. It's a way to divide up your SQL Server for different workloads. Force-seek, query hint, and table hints in general in plan guides. I will talk about plan guides at the end of this talk, and a plan guide is a way to associate a query hint with a query without having to put the query hint in code. Normally you have to code the query hint in code, and it's a big hassle to remember where they all are if you want to take them out. The limitation of plan guides in SQL 2005 was that you could not use them with table hints. You could only use them with query hints. And in 2008, you will be able to use them with table hints and force-seek table hint. Plan forcing for updates and deletes. SQL Server 2005 implemented plan forcing, which was the capability of you taking a plan from the plan cache and telling SQL Server, only use this plan. I don't want you to change the plan when the statistics change or based upon the cardinality statistics or estimates or anything else. Just use that plan. And there are some plan forcing improvements for update and delete, and also an easier way to create plan guides to implement plan forcing. So if you've ever been in the situation like I have, where Service Pack 1 comes out and some of your queries run slowly, and it doesn't look like SQL Server is choosing the right plan anymore, you can go back to pre-Service Pack 1, find the plan, tell SQL Server to use that plan. When Service Pack 2 comes out and they go back to using the correct plan, you just yank that plan guide out of the system and it's no longer used. Minimally logged insert, that's a new feature in 2008, and also spatial indexes. I'm going to talk after lunch about the new spatial data types in SQL 2008. And what good is a spatial data type if you don't have spatial indexes? So now, having gone through the whole list, I want to switch to another machine, virtual machine, and do a demo of SQL 2008 few performance features. And the reason I'm going to switch to this other machine, it's VMware, as you can see, is because VMware can use multiple CPUs per VM. And some of these are parallel plans, and I want to show you the parallel query plan. The first one I want to show is the multiple bitmapped indexes. So there's the bitmap filter example right here. This uses the AdventureWorks data warehouse, but it actually has to be quite a big data warehouse for this to kick in. So what we did is made a table of fact internet sales that's 3 times as big as the original fact internet sales table. If I do a select count from this, it should have about 250,000 rows, which isn't really that big for a data warehouse table. So the query that this is going to be using does a 3-table join between the time dimension, the product dimension, and the fact table. And notice there's a few predicates in here, calendar year between 2003 and 2004, and product alternate key is going to be like BK. So if I run this and look at the actual execution plan, you'll see what I mean by multiple bitmaps. Here it comes. So basically, this is a parallel execution plan. You can see that at the very end, there's a parallelism gather streams operator, which means it's going to gather all the parallel streams back up into one, has to do that to present the query to the user. But starting at the very beginning, at the bottom left, you'll notice that there is a table scan for the fact table itself, and it's doing a table scan based upon a certain key. And the key is actually part of the bitmap index. I'll go back to that in a second. Here's another table scan up here of the time dimension table. And so I'm going to have a join between the time dimension table and the fact table. Now, in previous versions of SQL Server, there's my bitmap right there. You can only use one bitmap to actually filter the query that I'm doing down here, the table scan that I'm doing down here. And I have one bitmap and that's it. Notice that it's filtering based on this index. If you look at the probe step, or the predicate step, the predicate step indicates a probe based upon the bitmap. In previous versions of SQL Server, this would scan the entire table. In this version of SQL Server, it will make up a bitmap filter and use that bitmap filter to optimize the scan. Notice that there are parallelism operators based on hashing at both parts of this scan. A parallelism repartition streams operator means that you have multiple threads coming in and multiple threads going out. And I can see that this particular step, if I click on it and choose View, Properties window, there we go, I can see that although the actual number of rows was 235,000, that some of them got executed on thread number 1 and some of them got executed on thread number 2. So basically, if I look at this repartition streams operator, second from the bottom, partitioning type, they've used the hash partitioning algorithm to be able to divide that hashing table, that probe into the hashing table, into multiple threads. And they've done that, they've made that faster based on the bitmap. Unlike other databases that actually, again, make the bitmap index and materialize it on disk, SQL Server will create the bitmap index for you automatically and use that for the probe step. And by the way, you could do this in 2005, but the limitation in 2005 is that you could have one bitmap step per query. In 2008, since this is a 3-table join, I'm going to do another hash join up here, the other half of the hash join. And before I do that hash join, I'm going to create another bitmap. And notice that we've taken the results from the first join and we pushed them into the second join. If I look at that repartition streams operator over there, they're actually using hash partitioning again. And I look at the, this operator coming in, notice that I do have a predicate, again, with a probe operator based upon that bitmap. So if I had one processor, they would have to scan the entire table. If you have one processor, it's not worth doing a bitmap create. It would slow things down. Because I have multiple processors, they can do bitmap create and use that to only scan certain parts of the table, and not only do it once, but do it twice. This is a new SQL Server 2008 feature that is meant to help out data warehouse queries, such as you'd see in reporting services or analysis services. So that's one change for the better. Next change I want to show you is grouping sets. And I want to show you a real cheap and easy grouping sets example. If you want to see some more complex grouping sets example, I'm going to do that talk on Wednesday at 9 o'clock. Basically, I have a small table in here using TempDB, and I insert multiple rows in it. And what I want to do is I want to have multiple sets of totals. I want to group by based upon the column A, I want to group by based upon the column B, and I want to group by based upon columns A, B, and C. This is equivalent to this union all query with 3 arms of the union. This one, and this one. The distinction is that with the grouping set, they will scan the incoming table once, and with the unions, they'll scan the incoming table multiple times. Let's turn the query plan on, actual execution plan, and we just want to run these back to back. And we'll notice that as far as the optimizer is concerned, the execution plan for the one at the top with the grouping sets is 40% out of 100. The execution plan for the one at the bottom is 60% out of 100. So according to the query optimizer, which of course can be wrong, the query plan with the grouping sets is better than the query plan with the union. Again, I say better than rather than faster than, because what a query plan is really the query optimizer's opinion of how the query will work. The query may work differently, for example, if the statistics are wrong. I'll talk about that later in the talk. So grouping sets give you an advantage, and in fact, if we look at those query plans a little more in depth, sorry about the small amount on a screen, but you either get small amount on a screen or small fonts. In the query at the top, notice that he is only scanning the table T twice. And if I look at the stream aggregate, I believe it's this one, and go over to the properties of the stream aggregate, notice that there's a new property that you can see in 2008 that gives you the roll-up information. And it says that there's multiple roll-up levels. He rolls up at level 0, and he rolls up at level 2. These guys, these two, are roll up at level 0. Subtotals, in other words, at level 0. This guy, I'm sorry, level 2. This guy is a subtotal at level 0. So multiple levels of roll-up. If you notice the query at the bottom, he scans the table 3 times rather than 2 times. And there is no roll-ups in the aggregates at all. So that's the distinction between using grouping sets and using multiple group by statements, putting in the subtotals with union all statements. That's another improvement for performance in 2008. One last one, and this is going to be an air demo because this feature isn't available in the CTP that I'm running. If you want to see this feature in action, come to the talk on Wednesday. There's only so many virtual machines that you can put up at a time. This one is going to be called Make Plan Guide. Let's see if I can just open this up. Create Plan Guide from cache. So in SQL Server 2005 or 2008, you can look at the query cache by using a dynamic management view called sysdm exec query stats. And I'm going to use that a lot more when I get back to the 2005 part of the talk. The query stats will actually show a handle for the SQL text and a handle for the query plan itself. And notice that this gets the query plan in textual format. The textual format is really XML, but the reason why they made it text is because the XML can get too big for the XML data type. So this is a 3-table join to try and get certain query plans out of the cache. And if I leave the where clause out, I'm going to get all the query plans out of the cache. There. There's all the query plans I've had so far. And by the way, we're going to do this more as the talk goes on. So if you want to freeze a plan, in other words, you have a good plan, you want SQL Server always to use that plan, you can execute the statement. I think I have AdventureWorks here. Execute the statement. And then once you have that plan in the cache, you can select the plan out of the cache with that join, use the plan handle as input and be able to get the plan from the plan handle with this query. And then this is a new statement in 2008. SP create plan guide from cache. Basically, a plan guide is a way to associate, like I said before, a query hint with a query without making it part of the statement itself. One of the query hints that you can associate in 2005 is the actual plan itself. In other words, tell SQL Server, use this plan. Don't think for yourself, I told you which plan to use. And it was difficult to make a plan guide like this in 2005. You could do it, but there was multiple steps that required going to Profiler and things like this. This is an easy one-step process for you to make a plan guide from the cache. One of the reasons, but not the only reason for this, is when you're converting from 2005 to 2008, you may see some queries that run slowly. Now, if 95% of the queries run quickly, faster, then possibly 5% of the queries can run slowly. So if you see a query that runs slowly, you can go back to the old system, make a plan guide from the cache, and then use that plan in the new system. I really wish we would have had this for the conversion from SQL 2000 to 2005. We didn't have this there because we didn't have plan forcing or XML query plans in 2000. So this is a new feature in 2005. Again, I'm not going to execute this because the CTP that I have doesn't have this yet. The CTP that will have this is CTP 5. Okay, so having taken a little bit of a look at the, having taken a little bit of a look at the new features in SQL 2008, I'm going to go back to SQL 2005. He said, there we go. So I want to go over optimizing Transact SQL code. Now, there's 2 ways that you might know to optimize Transact SQL code. The first one is the one that I've always used. The users point out when to optimize. Somebody calls you on the phone and says, the queries are running slowly. And the first question you have to ask when they call on the phone is, which queries? Is it SQL Server in general? Is it all queries? Is it a specific set of queries? Is it the queries that run at month end or at noontime? Which queries is it? Tell me. The other way to tune is something that I've really never had a chance to do, except at one job, which is proactive optimization. You finished your project, the project is finished ahead of schedule, and you have time to optimize. Just as a show of hands, how many people in their entire life, remember, I've been working at this since 1977, have ever had a chance to do proactive optimization? Yeah, look at that, not very many hands at all. People usually do it for the first reason. The users come up and tell them, okay. So what's running slowly? If the entire instance is running slowly, you can do something called bottleneck analysis. And bottleneck analysis is easily done in SQL Server with the help of sysdm OS wait stats in SQL 2005. In SQL 2000, you could get the same information with DBCC SQL perf wait stats. And although this is sort of outside the scope of the presentation, I wanted to show you the wait stats anyway. These wait stats are cumulative. And basically give you a list of all the things that SQL Server is waiting on. 203 buckets of things that SQL Server is waiting on. And they will give you wait times of each individual lock type, the latches that are taken on the system structures. For example, when I queried the plan cache in that last demo, I actually took a latch on the plan cache. That'll slow things down as well. Latches on pages, transaction marks. Some of the things actually should take up a lot of waiting time, like the lazy writer, right? The lazy writer only kicks in when it has something to do, and so most of the time the lazy writer is waiting. Another one that might take a long time is I/O completion ports. If the I/O completion ports have nothing to do, they're going to wait. You might guess that one called sleep task would wait. The distinction between 2005 and 2000 is, although the wait stats were around in 2000, they were undocumented. Unless you went up on a guy named Gert Draper's website and got a list of the documentation, there was no way to figure out what the wait stats meant. In SQL 2005, not only have they documented all the wait stats in the books online, but they have also given you a paper, 50-page white paper, called Tuning with Waits and Queues. So if you have SQL Server running slow in general, I would strongly suggest that Tuning with Waits and Queues white paper. Next. So which queries are running slowly? And you can specify the type of queries to tune. There's really two different strategies in this area too. One that I like is to figure out which of the frequently executed queries, I wonder why that ran off the top of the page, frequently executed queries, and a small improvement in a frequently executed query could give you a big improvement in real life. For example, if I have an online transaction processing system and I can deduce that a certain query is running 10,000 times a second, a small change in that query will make for a big change in the overall throughput in the system. And the one that you want to use for this is sysdm exec query stats. Let me show you this one. So sysdm exec query stats is a dynamic management view that gives you information about all the queries in the cache. The caveat to this is the fact that if your query is not in the cache, you won't see it. Makes sense. There's the query stats. So the query stats gives you, for each query in the cache, the handle to the SQL statement, and we'll talk about this in a second, the statement start offset and statement end offset. If you have a stored procedure, they can have more than one row in the query cache. They have one for each SQL statement. So this is the start offset and the end offset inside of that stored procedure. If the end offset is -1, it means it's an individual statement, not a stored procedure. Plan generation number. So how many times have they had to regenerate that plan? How many times have the statistics changed, or you added an index and they regenerated the plan? Notice that except for the ones on the bottom here, they've never had to regenerate those plans. A handle to the query plan itself, the creation date and last execution date of the plan. This is especially a good one, the execution count. One of the things that you want to do to make queries run quickly is to keep the plan in cache. And a big execution count means the plan has been in cache and executed for a long time. Notice this also gives you time in different worker threads, and it always gives you total, last, minimum, and maximum. The physical reads, and notice this gives you, again, total, last, minimum, and maximum. The physical logical writes, and it also gives you those 4 buckets for those, and the logical reads. It also, if you have a CLR-based stored procedure or a CLR-based user-defined function .NET-based, it'll give you the time that is spent in .NET. So a lot of people think that .NET procedures in SQL Server are sort of a black box. You can't see what's going on in those procedures. That's absolutely false. This is one of the things that you can see about .NET procedures. And then your best idea of what's going on, the elapsed time. And remember, this is total cumulative elapsed time. So you can take the elapsed time, divide it by the execution count, and get which queries are running slowly. Now, there's 2 pieces in here that sort of bother me, and those are, of course, the handles. The plan handle and the SQL handle. How do I use those to get the SQL and the plan? So I have in this set of scripts, which I'm actually going to give you at the end of the talk, I'll post them up, this 3-table join which they used previously to see not only the information about the stats, but also get the SQL text and the query plan. If I do that one against the plan cache, notice that this is a little more illustrative of what's going on. I have the text of the SQL. I put the execution count at the beginning because I like the execution count. And then at the very end, I have the query plan. And if you see a query that seems to take a long time, you can actually, since the query plan is an XML format, click on it, save it to the file system. So save the query plan XML as something. Save it as queryplan1.xml. And in fact, at this point, if you can save it as .sql plan, it's a lot nicer. So save it as queryplan1.sql plan. This thing seems to have the, okay, good, it did save it as SQL plan. Click on this, get rid of it, and then go back over to where you saved it, and if you double click, it should come up in the graphic query editor. There it is. That was a really cheap and easy plan, but any plan you can find in the plan cache, you can see in the graphic query editor, if you like graphic query editor. You can also, since these plans are XML, and of course, everybody did know that XML in SQL Server 2005 is a DBA feature. Everybody touts it as a developer feature, but it's really a DBA feature. If you know XML, you can analyze the plans in the cache. This is one that I wrote. Don't ever run this on a production system, which basically looks for certain physical operations in query plans in the cache. You tell it the operation you want, and it does a combination of a SQL query and an X query to be able to look for plans that contain that physical operation. And the reason why you don't run this on a running plan cache and a running system is it will put a latch on the cache. And XQuery in SQL Server is relatively slow, and you basically want to take this 3-table join, since that's all this is, and save it to a temporary table. And then you can play with the temporary table all you want. But this will tell you, if I catalog this, this plan will tell you which of the plans in the cache are using scans, clustered index scans. None of them. That's good. How about nested loops? Well, we have a couple with nested loops. And how about table scans? That's scan against a heap. Yeah, we have a few of those too. So the idea is that you can use this to trundle through your cache, and if you know more XML, you can figure out more stuff based on the XML plans in the cache. Okay. The other way to tune queries is what my wife likes to do. My wife has been a DBA for about 30 years, and what she does in any new job that she comes into is actually waits till month end, figure out whose queries are running the longest at month end. Usually you have the month end report, which includes some 6 or 10 or 20-hour queries, or man the phones and see who's complaining about queries running slowly at month end. Tune those queries, and if you tune a query that used to run for 10 hours down to 30 seconds, you have a friend for life, right? That's how she makes friends, right? Take my query that runs for 10 hours, tune it down to 30 seconds. By the way, if it's a user that's running that report, they might go to your manager and get you a raise as well. So either tune the frequently executed queries, the heavy resource consumer queries, or both. You can also tune queries, sorry that this scrolled off the page, that are slow because they're in lock weights. And you can analyze the lock weights to figure out which queries those are. So this is the PSS, Program Support Services, list of why queries run slowly in SQL Server. And they start with the ones at the top and work towards the bottom. The main reason why queries run slowly is because of suboptimal physical structures. Like what? Suboptimal physical structures like placement of files on the wrong disk, or lack of indexes, or lack of table partitioning. And so if you want to see if you have suboptimal physical structures, there's a tool for this. In SQL Server, under 2005 Tools Performance, there is the successor to Index Tuning Wizard called Database Tuning Advisor. And I'm going to run a real quick Database Tuning Advisor session. So Database Tuning Advisor is the successor to Index Tuning Wizard, but you can run it from the command line. You don't have to run it from the GUI. These things over at the side, I've been running this a lot. The things over at the side are actually XML-based, of course, project files. And you can run from the command line, point at these project files, and it'll tune whatever you want. The Index Tuning Wizard takes a file, and the file can either contain SQL or a trace, or point it at a table that contains a trace. I'm just going to use a file that contains a trace this time. There we go. And as opposed to Index Tuning Wizard, Database Tuning Advisor can tune multiple databases at the same time. I only wanted to tune this one. So there you have it. By the way, be careful when you use Database Tuning Advisor not to tune it against a single query, because Database Tuning Advisor is rather aggressive in what it suggests. And if you tell it to tune a single query, it will assume that that query is the only one that you ever care about, and will tune the entire system around that one query. So you do want a representative workload. You can limit the tuning time. I've actually had people say, I ran Database Tuning Advisor against the large trace, it ran for 6 hours and then crashed. Well, if that's true, you can limit the tuning time back to 4 hours, and then maybe it won't run out of whatever resource it's using. You can have it tuned for indexes and index views, or only index, or utilization of the existing physical design structures, or non-clustered indexes or index views. I'm going to just take its default. You can tell it I would like to employ partitioning, full partitioning, align partitioning, or not bother with partitioning at all. And I'm going to take its default here too. This one kind of worried me. Do not keep any physical design structures. You don't mean that by tuning it, it's going to drop all the indexes. No, that's not what it means. It means that it'll pretend that there's no indexes there. Or keep all the existing ones and just suggest new ones. Or keep the indexes, keep the clustered indexes, and keep the individual partitions that you have now. So you can give it a baseline of where you want it to start. With advanced options, the only advanced options are you can tell it how much room you have for indexes, new indexes, and it won't suggest any new indexes that are bigger than that. And you can say, if you're running a 24/7 shop, all of the recommendations are offline, meaning you have to take the system down to implement them, or only generate online recommendations, or prefer online recommendations to offline recommendations. In other words, this one, you won't have to take the system down to implement any recommendations he does. This one, you may always have to take the system down. We'll just leave it as default. Now, the hardest part about Database Tuning Advisor, from my point of view, is figuring out where the start button is. It's up here. It took me a while to do that. I'm sorry. I don't know who the GUI designer is that decided the start button ought to be there. And he's going through my workload, and he's tuning as he goes along, and it should be a fairly quick one, because I've done this before. It's also paging my machine a bit, so there we go. Okay, and it's consuming the workload, performing the analysis, and eventually it will come up with a list of recommendations. He said, "Are you done?" He's still working on it. He generates 15 reports, there we go, and recommendations. And notice that I didn't show you that trace, but the trace really covered about 20 different queries. He generated all these recommendations. Now, some of these are new statistics, so I'm okay with that. Some of these are new indexes. And so it's interesting that he generates a whole bunch of new indexes. Told you it was aggressive. Notice that it also said the estimated improvement on this workload is 63%. So if I implemented all of his improvements, all of his recommendations, it would be 63%. Reports, you can get a list of 15 different reports. And the ones that I found most useful are the index usage report for the current indexes and the index usage report for the recommended indexes. They will give you each statement that will use that index based upon the fact that you use that recommendation, and each one that uses it now. Now, once you've got the recommendations, you can do one of three things. You can apply the recommendations. I was fairly, let's say, leery of doing that, but it comes up and says apply now or schedule to apply later. That's good. I want to always schedule to apply later. In fact, I don't like the names that they put on these indexes, and so I would go and change them. The other one is save recommendations, and it save a bunch of SQL statements for you to give to the person that would run them at night and have them run those recommendations. The other one, though, is pretty interesting, evaluate recommendations. So suppose this guy recommended 20 things, and I only wanted to choose 5. We'll choose that one, and that one, and that one, maybe. Okay, 3. So evaluate recommendations will produce a new project that only evaluates, watch the thing on the left here, a new project that only evaluates, there's my new one, that only contains an evaluation of the 3 that I selected. So you can tune that one as well against the workload script and figure out what the % improvement would be if I implemented just those 3. Kind of nice. And again, like I said, these things are actually XML files that you can run off the command line every so often. So that's Database Tuning Advisor. Next reason why code runs slowly is because of missing indexes. And SQL Server 2005, believe it or not, has a bunch of dynamic management views that will show you which indexes are missing. And I think these are pretty cool. The index that are missing also show up in query plans as a yellow triangle if there's a missing index in a query plan. But for missing indexes right here, you'll notice that you get a list of not only index usage stats, but missing index details, missing index groups, and missing index group stats. I did the last 2 backwards. And you can figure out which indexes are missing. You also get a list of missing index columns. And if you tried to use these before, you may have noticed that although they know which column should be part of the index, they don't tell you which order the column should be in. Sort of a little bit of disappointment, but you can usually figure out by looking at the queries that are missing them what columns should be put in. Next one is lack of covering indexes. And by the way, there was a big talk last week at the developer conference of whether or not to use LINQ. That's language integrated query. One of the sort of things that I'm sort of leery about when it comes to LINQ is the fact that to get a nice object model from your database by using LINQ, it sort of suggests that you would have to use select star from a lot. If you don't use select star from, you get something called anonymous types, or you have to define every object in your type system. So select star from would sort of get away from the concept of covering indexes. In other words, all my indexes are useless. And I wanted to show you a real quick covering index demo because you've probably seen a million of these before. I always try and go with the simplest demos I can. So SP help index for authors shows me a clustered index plus a non-clustered index. The clustered index is AUID, and the non-clustered is last name and first name. If I do a select star from authors where last name equals white, you might think it might use that index on last name. It doesn't. And the reason it doesn't is because I did a select star from. The execution plan shows clustered index scan. How come? Well, its alternative was to actually get the last name, first name, and AUID from the index, and then go back and do a join with the table to get the rest of the columns. If I change this, in fact, let's just do the same query from authors where last name equals white. It'll actually use the covering index. It doesn't read the table at all. There. So by cutting down the number of columns in your select statement to just the ones that you need, you can optimize the statement to use a better query plan. If I add one more column to this, select AUID, first name, last name, and city, it can't use the covering index anymore, and now it's back to clustered index scan. Even if I said where last name is equal to white, just to get that one column. What did I just do? Just to get that one column, could you cut and paste? There we go. I'm going to have to go back and I'm going to have to get the entire table. So now we're back to cluster index scan again. Real simple, illustrates it exactly. I can create an index that includes the city column, and by the way, this included column is not a part of the key. And then, of course, you will see it use that index. There. And notice it's doing an index seek on my index that I just put in. So lack of covering indexes is right up there at number 3. Number 4 was pretty surprising to me. That was lack of indexes on computed columns. I didn't realize that that was such a big issue, and in fact it turns out that a lot of people really don't use computed columns as much as they could. Here's an example of where I could use computed column. And in fact, I have a computed column right here. It's the total column. So this is total is price times quantity plus the sales tax for King County. If I do a query like this, select sales ID and total from sales, where total is greater than 20, it's going to use that total, but if I look at the query plan, it's going to do a cluster index scan for that. There's no way that it could use a predicate over that part of the total. Now, if this formula right here is deterministic and precise, and it is precise because it uses decimal data type, and it is deterministic because the same input always returns the same output, I can make this a persisted computed column. In other words, persisted in the database. I don't have to do that formula each time. Notice that in this query plan, if I go and view the properties window, the properties window is for the stuff that doesn't fit in, hover over help. You'll notice that I am doing that computation each time. There's the computation right there. If I don't want to do the computation each time, I can make this persisted. Persisted computed columns exist only in 2005 and above, but in 2000, if my formula is deterministic and precise, and also in 2005, I can make an index on the total column. And so let's make an index on the total column. Great. Now, of course, my query will use that index because there's a predicate on the total column. I could use that index to satisfy the predicate. And because I'm only getting sales ID and total, I can use that covering index right here. It actually does a constant scan to be able to make that constant of 20 into a decimal data type. I'd have probably been better to use a parameterized query here or to make this specifically a decimal data type so that they would know they wouldn't have to do all this constant and compute scalar thingy up here. But basically notice that the query plan has been pushed down to an index seek. And it's index seek because I have not only a covering index, but one against a computed column. Now, the reason why these are often forgotten about is because your database doesn't include the computed column when you start. So suppose I only had quantity and price, and I assumed I was always going to calculate the total. Now, if I put a computed column in there, that computation might appear in my query, but the computed column itself, in other words, the total column, does not appear in my query. In other words, I might have query that looks like this. And a query that looks like this, you would think would never use this computed column because it's using just the formula here and just the formula here. And so, therefore, putting in a computed column would mean that I would have to go in and change all my queries to name that computed column, like I did here. Turns out that's not true. If I altered the database to set parameterization to forced parameterization, and I'll talk about auto-parameterization later on, with forced parameterization, they will use that computation. They'll determine that the computation is the same as the index, and they will use it even though you do not name the column. So that's pretty cool. If you have computations that you use all over the place, you can make a computed column that pre-computes those. You don't have to go back and change all of your queries. However, parameterization must be set to forced. If I go back and set parameterization to simple, which is the default, he goes back to the other plan. Actually, he didn't go back to the other plan. Oh, because I'm altering database pubs, Bob. Nice going. TempDB. Now he goes back and uses the other plan. There, cluster index scan again. So the idea is parameterization set to forced, you don't even have to name the computed column. Just using the formula will have it use the computed column. Next one, out-of-date statistics. So SQL Server automatically generates statistics against two items. It will generate single column statistics if you need those statistics, and it will generate statistics on indexes. I want to show you these because in this version of SQL Server, those statistics even appear in the graphic user interface. In the database GUI, under pubs, under tables, if I look at the authors table right here, notice that for each table you'll see statistics as one of the choices. You can click on statistics and you can specifically right-click and see the properties of those statistics. Statistics consist of two items, cardinality estimates and density estimates. Notice that this statistic is on an index, and for index-based statistics, you can see these. There's the estimates right there. Density is the number of rows in a specific range. Cardinality is the number of rows on a per key range in buckets. And the histogram buckets can go up to 200 buckets. Can't have more than 200 histogram buckets. So you can see the statistics if it's based on an index. SQL Server will also automatically make statistics if you give it a query where it needs them. Go back to my pubs database again. Select star from authors where state, if I could spell, where state equals California, like that. And it will make a automatic statistic over state. There. If I refresh those, there we go. You can see that the automatic statistics always start with _WA_sys. I do not know why, but that's a really good indication it's an automatic statistic. If I go and look at the properties of these guys, you will notice that that is the index over the individual state row. So there you go. With automatic statistics, I cannot see the cardinality of the histograms. Notice, or the density of the histograms. Neither one is available. So that's automatic statistics. Automatic statistics are on a per database basis by default. You can turn them off on a per database basis if you want to. And you can turn them off with DDL, it's an alter database statement. Sorry. There we go. By saying auto create statistics equals no. SQL Server will also automatically update statistics for you. And they automatically update statistics when certain limits are produced. For example, in a regular table, they will automatically update statistics at the 50th row that you insert, the 500th row that you insert, and after that, if 20% of the rows have changed. With a temporary table, they will also update the statistics when the 6th row has been inserted. And you can turn this off on a per database basis with auto update statistics. You can tell it auto update statistics off. Unfortunately, there is no way that I know of to automatically turn this on and off on a per table basis. It's always on a per database basis. Why would you want to turn it off? Well, at Microsoft, they have a product called BizTalk. And BizTalk is a service-oriented product that deals with messages. They actually use certain tables as queues. So message arrives from the outside world, they put it in a queue. And then they finally process that with another part of the product. Well, if you have tables that are queues, your statistics are usually worthless. They're constantly putting in and taking out and putting in and taking out rows, and therefore there's no reason to have statistics at all. The statistics will usually be wrong, and they'll spend a lot of time recomputing them. So in BizTalk, they actually have auto-create and auto-update statistics turned off for those databases with queue tables. Now, how do auto-update statistics work? Well, in order to see how auto-update statistics work, I want to go back to talk about query plan. Here's query plan. And this is a build slide, so I hate build slides. There we go. So first thing that happens is a statement walks in off the street, and SQL Server has to decide whether or not it's going to use a query plan that he already has or build a query plan. Building a query plan takes time. In fact, you can have excessive CPU utilization just by recompiling query plans all the time. So SQL Server will reuse a query plan if there is one in the cache that matches. So first thing he does is look in the plan cache. If there's one that matches, he's done. He goes down to this step. If there isn't, he goes to the next step, which is to parse the statement out, to possibly auto-parameterize the statement. I'll go over auto-parameterization in a minute. Bind and expand the views in the statement, because views are just SQL statements disguised as tables. And then do query optimization. Query optimization consists of generating plans, view matching, and looking at the statistics to figure out which plan has the lowest cost. SQL Server actually uses a 4-step process to figure out the best query plan. The first step is called trivial plan. If SQL Server sees a trivial plan, select star from authors would be a trivial plan, then it chooses that plan and he's done. Next step only happens if you have 4 or more tables in the query. And in that step, SQL Server will use a subset of the rules of plan optimization and try and get an optimal plan. If he gets a plan with a plan cost of less than 1, he stops and he gives back the plan. If not, he goes on to step 3. Step 3 executes for any number of tables. And in step 3, he tries to get a plan quickly with a subset of the semantics, a subset of the rules. And if he gets a plan with a cost of less than 1.2, he stops and sends it back. Step 4 is the step of last resort. Step 4 is like playing chess with a computer. Anybody play chess with a computer with a time clock? You hit the thing and then that person has that much time to make their next move? Well, SQL Server is using a time clock. And he starts to call in all of his statistics, all of his different indexes he might use, reconsider every part of the plan that he could use differently, and he can come up with sometimes billions of plans. However, when the clock runs out, he chooses the one with the least cost. Now this sort of harkens back to, and I do want to finish this build slide, this sort of harkens back to one of the reasons on the bottom why queries run slowly, which is that you have too many tables. SQL Server can optimize well up to about a 20 to 25 table join. After 25 tables, there's too many choices. If anybody has ever had a 150 table join, and I had somebody in my class 2 weeks ago that said that they hit the limit for numbers of tables that could be joined. Anybody know what that limit is? 256. If you have a 256 table join, that's too much. SQL Server won't even be able to call on the statistics for all of those 256 tables. In fact, I would knock it down after about 20, right? Because after about 20, the number of possible plans is up in the billions, and he's going to run out of time before he can do anything else. So after he's chosen the query plan or found one in the cache, he generates something called an executable plan. And query plans can be used by multiple people at the same time. Query plans are reentrant and reusable. If I have 5 people doing the same query, they will have one query plan. Doesn't matter. And if one of those people goes away and another one comes in and does the same query, they will use the same query plan, reentrant and reusable. Execution plans, executable plans, are reusable but not reentrant. They contain things like the query parameters for that part of the plan, for that query. So if 5 people are using the same query at the same time, there is one query plan and 5 executable plans. If one of those people finishes and another person comes in and does the same query, they can reuse the executable plan. So there will still only be 5 executable plans. Executable plans, one more time, are reusable but not reentrant, whereas query plans are both reusable and reentrant. They can be shared by multiple people. So it generates an executable plan, or finds one that's correct, that somebody else has used. Fix up the memory grants and the degrees of parallelism. If you have a parallel processor and SQL Server decides that it's worth it, they will always generate 2 plans, one for parallelism and one without parallelism. And he chooses at the very last minute the degree of parallelism based on which of the processors is being used, how many are being used, and so forth. So that's the next thing he will do. Memory grant is based upon the fact that some of the query iterators require memory grants. And what I mean by memory grant is this. If I do a select star from authors where state is California, order by state, how about order by, state would be good enough. You'll notice that let's do the first one first and show the plan. So we do this, and notice that in the select statement of the plan, we have cache plan size, degree of parallelism, operator cost, subtree cost, and number of rows. Remember that. We put in order by. Go back and look at the plan. He optimized that away. That wasn't nice of him. Okay, order by zip. He doesn't have a statistic for that one, so there you go. Order by zip code. Now there should be a sort step, and notice there's another row up there. Cache plan size, degree of parallelism, memory grant. What's memory grant about? Well, memory grant is based upon the fact that some of the query iterators, like sort, or hash join, or hash aggregate, require memory. How much memory? It depends upon the estimated number of rows coming into that sort. So if SQL Server knows the estimated number of, well, it's going to know the estimate of the number of rows, it can do a memory grant for that sort. If the statistics are wrong, back to statistics, and it guesses low, then it's going to run out of memory. And it's going to have to allocate memory while the query is running. Not a good idea. If it guesses high, it's actually going to allocate too much memory and waste it. So that's memory grant. And memory grant. And so he fixes up the memory grant and the degree of parallelism at the very end. Sorry, I hate build slides, and this is why. I can never stay on the page for long enough. I have to show you something, right? Fixes up the memory grant and the degree of parallelism at the very end, executes the query, and unless you say otherwise, returns the plan to the cache. So notice the statistics are used in query optimization. Now, reason I pointed that out is because when does updating of statistics take place? Updating of statistics takes place during query plan generation. If it decides it needs new statistics, how does it decide it needs new statistics? 5, 50, 500, and 20% of the rows have changed. By the way, in SQL 2005, it's a little different than SQL 2000. In SQL 2000, if you change any of the columns in the row, they keep what's called the row mod counter, and that's how they decide if the row has changed. In SQL 2005, that row mod counter went away. It actually contains zeros now. And instead, they keep track of the changes on a per column basis. What's nice about that? If you change the state 50 times, but you don't change the author's last name, they will never update the statistics on last name. Cool. That's great. So, like I said before, he stops right in the middle of the query plan to update the statistics. In 2005, you can do auto update statistics async. Auto update statistics async allows him not to stop in the middle of the query plan, but to give the person who's doing that query a bad plan, and then spin off a thread to update the statistics in the background. If you have users reporting that things are fast, things are fast, things are fast, and then they're slow, you might be running into this auto update statistics sort of hiccup. And if that's the case, if you want to smooth things out for the users, at the expense of possibly having a bad plan, auto update statistics async. So let's go back to the reasons why queries run slow, because I'm running short of time, like I always do when I do this. Okay, out-of-date statistics. So let's talk about non-parameterized queries. SQL Server, when it matches query plans, always matches based upon string compare. String compare? Yes, string compare. Let's go over here to my diagnostic set of queries. Let's lose this thing so you can actually see. Go over to my diagnostic set of queries and clear the cache. So there's clearing the cache about 3 different ways. And now if I do this query, we have no cache left. There. So now what I want to do is show you auto-parameterization. So first of all, they don't auto-parameterize every query. What you'd mean by auto-parameterization is changing this to a parameter automatically. They do not auto-parameterize the having part of the query. So if I go to the pubs database and I run this query, in fact, let's just go to the pubs database like that and run the query like this, you'll be able to see in the query plan that there's a plan for that query. It's right here. In fact, I'm getting the plan for this one too. Let's take it out. There. So now there's a plan for that query with a use count of 1. If I go and execute the query again, there's a plan for that query with a use count of 2. No big deal there. Notice that SQL Server does string compare. Are you ready for this? Take the same query and insert a comment. It's just a comment, right? Do they use the same plan or not? No. This one's the one with the comment. This is the one without. I always wondered why there were some developers that actually took their queries and put them as string constants in programs. Now I know, right? If you let every programmer code their own SQL, they will possibly mess up the query plan reuse. Another thing that I can do to mess up the query plan reuse is put extra space over here. Now string compare doesn't work either, and so I get another plan. Really? Well, yeah. There we go, with the extra space. So if SQL Server sees a non-parameterized query, it's going to have to match with string compare. Let's look at auto-parameterization, though. Here's an auto-parameterized query. It's really easy to see what I mean by this. Go back and look at the plan in the cache, and there we go. They have changed the query to this. Select star from titles where price equals @1. But @1 is defined as a parameter of type money. How did they decide it was money? There's a $sign in front of it. Will subsequent executions use it? Sure. Next execution of the same query uses the same plan. Execution count of 2. But how did they decide it was money? They guessed. How did they guess? Well, they saw the $sign. What if you take away the $sign? Is it money now? Depends on if I have forced parameterization on or not. Let's see if I do. Nope, it's not. It's numeric 3, 2. Oh. So it makes it different whether I have the $sign or not? Well, apparently. And numeric 3, 2 would really mean that for this one, they would guess numeric 4, 2. Correct? Correct. 2 plans. Different numeric types. And by the way, for integer types, you're going to see tiny int, small int and big int the same way. So the best thing to do is not let SQL Server auto-parameterize your queries at all. You should parameterize your queries yourself. Don't let SQL Server do this. He's guessing. And by the way, if you use, or programmers have used ADO.NET, do not use parameter.addWithValue. That makes ADO.NET guess. Great. And he's no better at guessing than SQL Server is. Here's a better way if you really have to use dynamic SQL, SP execute SQL. That's a price defined as money that's $19.99. This is also a price defined as money. I don't have to have the dollar sign down here. So these two will reuse the same plan. If you use parameterized SQL statements and name the parameter type, you will always reuse the same plan. If not, you're playing string compare. Right? So lack of parameterization is one great big reason why queries run slowly. The last thing is too little or too much compilation. Non-parameterized queries can cause excessive compilation time. Something called parameter sniffing can cause too little compilation time. I want to do the parameter sniffing example. We already talked about overly complex queries, and then I'll take questions. And by the way, you'll have this code so you can play with these yourself. Here's the parameter sniffing example. There. So first of all, to start out with, SQL Server will never use a parameter value against statistics when it is set in code. Here's a parameter value against statistics when it's set in code. This is in AdventureWorks. I was looking for a use statement. Okay, there's my use statement. This is against AdventureWorks. The parameter is set in code. Let's do this query and let's look at the query plan, by the way. Let's knock off the query plans first so I can see them. That's not knocking them off, Bob. That's showing them again. There. Flush the cache. Go over to AdventureWorks, do this query. When I do this query and look at the plan, he said, there. You'll notice that I get a plan with a wild cardinality estimate. This query actually returns 96 rows, but this plan is using a merge join. And it's using a merge join because it doesn't think it's going to return 96 rows. It thinks it's going to get 9,439. That's off by what, 100? Factor of 100? If this used a hash join, it would mean my memory grant would be 100 times too big. Oh, how come he didn't use the statistics? Let's make sure that he can use the statistics if he wants to. Rather than setting the parameter in code like this, let's set the parameter hard-coded like this. There's the same hard-coded parameter, same query, same number of rows affected. Because it is a hard-coded parameter, he won't reuse the same plan. Watch this one. Nested loop join. Merge join is good for medium number of rows. 9,600 is a medium number of rows. Nested loop join is good for small number of rows. He really has a small number of rows, 96. If I look at the estimate coming in from the top again, estimated number of rows is 40. Oh, that's a big difference between 40 and 9,300, don't you think? So I always thought that it was a good idea to set my parameter value in code and use parameterized queries. You do use parameterized queries for query plan reuse, but this way actually uses the statistics. Is there a better way than both of those? Well, of course. The better way than both of those is to use stored procedures. Let's create a procedure that passes in the parameter. And when it passes in the parameter, SQL Server creates the query plan right here. So it knows the value of the parameter. In the previous two statements, SQL Server would produce the query plan when it got to this statement right here, first statement in the batch. Does it know what the parameter value is then? No. In this one, it would produce the query plan right here, first statement in the batch. Does it know what the parameter is? Yeah, there is no parameter. It's hard-coded. So stored procedure gives you the best of both worlds. They know what the parameter is on input, and then they can use the right statistics. So if I catalog this as a stored procedure, there's already one in there, okay, and execute it, do I get the right plan or the wrong plan? We already know what the right plan and the wrong plan both look like. 96 rows affected, same query. I get the nested loop join. I get the right plan. Again, this is called parameter sniffing because SQL Server will never use parameters that you set in code like that, but they will use parameters that you pass in like this. They sniff the value of the parameter on entry to the procedure. Okay, can I do worse or better than that? Here's one that I like a lot because it demonstrates something even worse. Get recent sales. And get recent sales has a date time passed in. This is a different procedure than the last one. But notice what this code does. If date is equal to null, just get me the sales from 3 months ago, 3 months from the previous sale. So apparently the most common value when it's passed in is null. They'll get you the sales from 3 months ago. If it's not null, then they'll do the select statement. If I create the procedure like this, it's not going to work that way. If I create the procedure like this and run it like this, I could spell, I'd be dangerous. There we go. What's the actual value of the parameter going to be? Well, by the time I get to the select statement, it will be this. What's it going to optimize based on? Null. So if you look at this query and look at the plan produced by this query, you'll notice that he chooses nested loop join. Where's the query plan right here? There it is. Remember, this is a different query than the previous one. It's not the same query, but he's choosing nested loop join. Why is he choosing nested loop join? Because he thinks there's very few rows. Why does he think there's very few rows? Because there are very few rows. In fact, there are no rows where this sale amount is equal to, or sales date is equal to null. So he's optimizing based on a value that he never has. Great. And by the way, how many rows were returned from this query? Oh, 19,000. So he did what? 19,000 nested loop joins. Oh, why? Because I wrote code that looked like this, right? What's a better way to write code that looked like this? Well, one way is to make SQL Server recompile each time. You can declare the procedure with recompile, like that, and that's kind of nice, but that recompiles every query in the entire procedure each time. You can execute the query in 2005 with the query hint, and this query hint is option recompile. There. And that actually says, compile the query, but don't store the plan back in the cache when you are done. Because that's an odd query plan. I don't want it for next time. Option recompile. Now, I said parameter sniffing is usually a good thing because it allows you to reuse the same plan. The problem is that it can also be a bad thing. Imagine the following scenario. The following scenario is, I have a company that's based in the US, and that company has 100,000 customers. And I've just opened a branch office in Australia. The Australian office has 2 customers. They just opened yesterday. I want to do a query with a 5-table join that starts with the customers table. Which plan is he going to use? Well, it turns out, and I know this for a fact, because of the time zone difference, the people in Australia always get in first, always get into work first. So somebody bounced SQL Server over the weekend to do maintenance. It came up first thing in the morning, and the people in Australia hit it first. Parameter sniffing says that they will generate a query plan that's optimized for Australia, 2 customers. Then the people from the US come in, and they get the same plan. Why? Because the statistics haven't changed. Right? That's why. Now they're doing their nested loop join for 100,000 customers. That's where parameter sniffing works against you. If parameter sniffing is working against you, you can use dynamic SQL, which isn't really a good idea in any case. You can use create procedure with recompile, or you can use option recompile on the statement. But again, that recompiles the query each time. Suppose I decide that it's better for the Australian people to use a merge join, they only have 2 customers after all, than it is for the US people to possibly use a nested loop join, or it's better to do that than generate a new query plan each time, because there's going to be 1 million people from the US eventually doing that query. And I don't really want a new query plan each time. Can I do something about that? Yes. SQL Server can only use 1 query plan per query. There's no way to make multiple query plans for the same query. But if I decide that the Australian people can suffer with it, I can do this. Option optimize for. And then I name my parameter. In this case, it would be date equals some date. But optimize for date equals some date, or optimize for country equals US, or optimize for something else. So this is a query hint that I can put in here. Now, when my number of customers in Australia gets bigger, I want to take that hint out. But the hint is in my query, not a good thing. So in SQL Server 2005, there's something called a plan guide. And a plan guide allows you to, and I'm going to just show one really quickly because I'm out of time. Oh, that was good. Plan guide associates a plan with a query without putting it in the query itself. This is under here. And basically, this is just a whole raft of plan guides. I want to show you the optimized for US plan guide. By the way, that's a plan forcing plan guide. It says use this plan. You don't ever want to put that in a program, right? Use this plan in XML format. Okay, so here's plan guide. If I want to have sales order by country too, here's my query, here's my stored procedure, and this plan guide says, when you see this query in this stored procedure, apply hint optimize for country equals US. And then when you have 100,000 customers on Australia, you just take that plan guide out. You don't have to go look for all the places in your code where you've changed it. So again, what I've done in this talk is I've gone over the 10 reasons why queries run slowly. I've also talked about some new optimizations in SQL Server 2008. I've showed you examples of the optimizations and why queries run slowly. And I've talked about plan forcing and plan guides. If there's any questions, I know it's lunchtime, I'll be up here afterwards. And thank you for staying this late, and I appreciate it.